Hi, it's Professor Davis. Here's your topics checklist for sections 5.4, 5.5, and 6.2. This topics checklist kind of serves as a transition, so to speak, from the discrete probability distribution models to the continuous probability distribution models. So let's take a look at section 5.4. In that section, that section serves as a continuation of what we talked about in section 5.3 on the binomial distribution. And what we're looking at here is the mean, variance, and standard deviation specifically for this distribution. In section 5.2, we talked about how to find the mean and standard deviation in general for a discrete probability distribution, but if we know it's binomial, the formulas are much easier. If we have a given probability of success P and number of trials N, we first want to be able to find the mean of the distribution. We simply do that by multiplying N times P, the number of trials times the probability of success. To find the standard deviation, we take the number of trials times the probability of success times the probability of failure, and then take the square root of that product. That will give us the standard deviation. That's sometimes called the square root of n times p times q. Q is sometimes used to denote the probability of failure. In other words, the complement of the probability of success. As far as doing things with the mean and standard deviation, we want to be able to identify any unusual values by computing values that are more than 2 standard deviations away from the mean. So that's why we want to compute this value of mu plus or minus 2 sigma. That will denote values that are more than 2 standard deviations away from the mean. And then to finish off Chapter 5, we want to take a look at Poisson probability distributions. This is a binomial type of distribution for a small probability of success and a large number of trials. And so we only have one parameter here, which is mu, and we get that by multiplying n times p, or sometimes we're simply given mu. There's only one parameter with the Poisson probability distribution. That's what makes it so easy to compute. So we want to be able to compute probabilities using the probability distribution formula. And to help you with that, I also have a statcast on the Poisson probability distribution in the statcast area. And then finally, for this checklist, we have section 6.2 on the standard normal distribution. So here, we want to take a look at a couple continuous continuous random variables. First, the uniform random variable, and so we want to be able to compute probabilities using the uniform distribution. In other words, the probability is the same over a closed interval. And then after that, we want to be able to compute the normal distribution probabilities given z-scores. So we want to use that standard normal table. It's table A2. You'll find it in the appendix of the ebook, and so you want to have that handy to be able to compute normal distribution probabilities. And you can also use your calculator to get those if you feel like it. Table A2 is kind of a quick and easy way to compute standard normal probabilities, so you want to be able to practice that and be able to use that. And then we want to kind of do the opposite. In other words, if we have a known area under a normal curve, a bell curve, so to speak, we want to find the z-score that matches that. So we're kind of doing the process backwards. We have a known area under a normal curve, and then backtrack. In other words, use table A2 in reverse to see how we find the corresponding z-score. So for practice exercises this week, starting on page 232 in section 5.4, we have exercises 5 through 13 odd. In section 5.5, starting on page 238, try 1 through 11 odd. And then finally, some practice there for computing normal probabilities in section 6.2, starting on page 261, problems 5 through 39 odd. So that is your topics checklist for sections 5.4, 5.5, and 6.2.